So Mercury has this rate right here. What is the rate of argon? We want to set it up so that our unknown is in the numerator. So rate of argon over the rate of what we know, that's the mercury, square root of, and these are flipped, so molar mass of mercury over molar mass of argon. So we can just call that X if you like. 7.2 times 10 to the minus 6 moles per second equals the molar mass of mercury, which is that 200 number, over the 39.95. Those are both grams per mole. Now we'll bring this over and we'll say 200.59 divided by 39.95. And then we'll take the square root. Second. Oh. Can't get my square root key to work. There we go. And I'm going to do that of my answer. So I've gotten the right side taken care of. Now what I need to do is cross multiply, or you can just say multiply both sides by 7.2 to make sure it doesn't end up under the square root. So 7.2 times 10 to the minus 6. So those two cancel. 7.2 to the minus 6th. And so that's going to give us that x is equal to 1.6 times 10 to the minus 5th. And then the next problem, argon moves at a fourth the rate of another gas. What is the other gas? All right, so a good way to go about these is just to try to pick a random number. Sometimes that helps everyone. So the rate of argon is going to be equal to, let's just pick 1 mole per second. That would not be the rate, but it's just, we're just grabbing a number to get the ratio right. So if that's that rate, it says it moves at a fourth the speed of another gas. So it's 4 times as slow. So the rate, I'm going to use U for unknown, is going to be 4 moles per second. And that's how we can say that argon's slower. So we know those two things. We also know the molar mass of argon because we've used it a few times, 39.95 grams per mole. So what we don't know is the molar mass of the unknown. So again, set that in the numerator. So when we set this up, our molar mass of unknown is going to go here. This is what we know, that's argon's. And then when we're doing this way, that means that this has to be the rate of argon, and this has to be the rate of the unknown. So then we can say 1 over 4 equals the square root of an unknown over 39.95. Now you need to square both sides because we can't deal with an unknown inside of a, inside of a square root. So if we square both sides, we will get 1/16 is equal to the molar mass over 40. And so we get 40 over 16 equals the molar mass. Oops. And that's 2, it comes out to be 2.5. Now with these, sometimes you have to have a little bit of guessing room. If it says for sure that it's an element on the chart, then the closest gas to that is 2.01 grams per mole. 2.02 grams per mole. Even though I know that's not that close, I'm just saying if that's what it says is on the chart. Or this could be some unknown gas, right? It could be that too. So anyways, if I were to guess, I'd say that's the closest one, and being the closest, that would be H2.